Hello and welcome to the IPv6 deployment. Hello and welcome to the IPv6 deployment session. My name is Anna and it is my pleasure to be your host. Before we start, let me iterate some of the housekeeping. First, please be mindful of the code of conduct. It is published in the conference website and also in the chat box. If you want to ask questions to our speakers, you can either use the raise hand function in Zoom and you'll join the queue for voice questions, or you can type it in chat and start it with the word question colon, and I'll read a question for you at the appropriate time. And if you are taking photos or selfies during the conference, why not share them in Twitter or Facebook using the hashtag APRICOT 2022, and there will be prizes to be won at the end of the conference. That's all from me. I'm now passing the mic to our moderator, Kenny Huang, to introduce our first speaker. So over to you, Kenny.
Okay, right. Thank you, Anna. And good morning, good afternoon, good evening, everyone. Welcome to the IPv6 deployment section. And as Anna already mentioned, this session will focus on the IPv6 deployment progress and experience best practice among all the operators. So I have the honor to introduce today's first speaker, Jeff Hewson. Jeff Hewson, everybody knows Jeff Hewson. He's the chief scientist of APNIC. He is going to give an update on IPv6 fragmentation, and pass to you, Jeff.
Thanks a lot for that, Kenny. And I will get straight into it because time is, of course, of the essence here. So I'm going to talk about IPv6 fragmentation. You know, when we did V6, we actually tried to change as little as possible. And by and large, you know, we changed as little as possible. A few fields in the V4 header, though, were pushed into this new concept called an extension header chain. And that extension header change is optional. So it may or may not be there. What came in its place was the flow header. So those were the actual changes. You know, the type of service was traffic class. We don't know what it means, but it's there. We have a flow label. We don't know what it means, but it's there. Whoops. The header checksum's gone. That's media layer. And now we've got extension headers, including packet ID and fragmentation. Now, that was the big change because fragmentation was actually the thing that made V4 work over all kinds of networks. You could take a 1500 octet thing coming off at Ethernet and slice and dice it and put it into an X25 network that just didn't know what to do with a packet more than 3 bytes or something. Yay, X25. But fragmentation on the fly was a key asset. And so in V6, this was a big change. Now, we didn't really worry about it much until Fernando Gont and a few others actually did some testing. And this was published, RFC 7872, in 2014, I think was the tests. It was published in 2015. And they took the Alexa million at the time, and they sent them crafted packets. And those packets had a destination option with padding. It had a hop-by-hop option with padding. And it fragmented the packet down to 512 octets. And those percentages are the percentages of things that got dropped. And what it said was, for web servers, 1/3 of the packets that had fragmentation on the Alexa Top Million never received the packet. That's bad. 1/3 is terrible. So the initial tests were disturbing. Now, fragmentation is often dropped by firewalls, but equally there's this whole issue of packet size and what we call the maximum transfer unit, the MTU, because V6 did a rather bizarre thing. Instead of using the IPv4 model that only, God, what's the IPv4 model? Any packet larger than 576 octets might get fragmented. Yay. In V6, that's redefined to being 1280, but it's a bit harsher than that. What it says is you must support up to 1280, but after that, it's optional. Why 1280? Everyone's forgotten, but in actual fact, it's what you get when you add 256 to, what is it, 1094? It has no meaning. It was just a number. 1280 was just picked out on the fly. Anyway, extension header chains and fragmentation have caused a problem. Part of the issue is that when we put a variable sized shim into a packet, if you want to find the port control blocks, the transport headers, it's at a variable offset. And if you're a piece of silicon trying as desperately fast as you can to shovel packets around and you're looking for where the transport header is, it isn't going to come out in one lookup. You've actually got to unravel a chain. So if you're doing that kind of transport-aware switching, in V6, you've got a real problem if there's an extension header, and particularly with a fragmentation extension header. Now, that test that Fernando Gont and that crew did was actually, I think, the wrong way. It was sending a packet to the server. Big packets don't get sent to servers. Servers send big packets to clients. And so we thought, let's reproduce this experiment. A few years has passed, and we will do it the other way. We will take lots and lots and lots of clients and use our server, and we will send back huge packets, and we will then fragment them and then send them on their merry way. And we will send it through the DNS to see how the DNS goo manages fragmentation. And we will send it end to end on a TCP connection. In fact, on a TLS 1.3 connection, because we're going to use HTTPS and we're going to frag the packet, right? So we did this test in August 2017. And while RFC 7872 said 28% drop, we saw a 21% drop. We're going, well, 3 years have passed. Maybe we're getting better at this, maybe. But we thought we'd come back to it last year, so we did. We're using a subtly different form of experimentation now, but it's very similar. What we do is we take an outgoing packet from an HTTPS server, a standard server, and we push it through a sort of a middle box, a packet mangler. And that mangler will fragment that outgoing packet. Now, how do we detect that the client, some random web browser thing, has actually received the packet? Well, the beauty of all this is that underneath all of this TLS and so on is still TCP. And the ACKs aren't encrypted. This wouldn't work if we used Quick. So yes, this has to be TCP. So we're looking for ACKs. And we did one more thing, but just for grins. Rather than just fragmenting to a fixed size, we varied the initial fragmented packet size between 1200 and 1416 bytes in 8-byte increments. So we tested a whole bunch of sizes to see if there was any difference in the drop rate. And rather than just doing a one-off measurement, we've been measuring every day since. We do these days about 18 million experiments a day. And so there's a fair body of measurement. The packet mangler was a huge amount of work. There's a slide to say, God, it was difficult. Shared memory spaces, buffers. It took some time to get this all working, but, we managed. And here's the basic answer for data right up until a couple of days ago. This is the world's users running V6. So it's not or everyone, it's the ones that actually have end-to-end V6, approximately about 30% of the world's users. And we're looking at the overall average fragmentation drop rate day by day. Isn't it odd that weekdays are better than weekends? If there is enterprise V6, folk get to handle fragmentation better than your friendly V6 supporting ISP, because on the weekends, it's worse. Don't worry about the red line at the moment. And that massive peak there in December, January, I'm sorry, we did an oopsie, and don't look at that data. That was a bad period. So, things have come down a bit, and currently it's around 7.5% or so. So it's actually a lot better than 21%. Where? Now, this is interesting. Green is good, red is bad. And this is only looking at V6. So if you have V6, you're coloured. If you don't have V6, and parts of Africa don't have enough to measure, then, the colour doesn't matter. It just isn't there. But if you look at what's green, you actually find India, a relatively recent V6 deployment. Australia, a relatively recent V6 deployment. The earlier V6 deployments have a more checkered history. And some of them are kind of mediocre to don't really like what I'm seeing here. So in some ways, the more recent v6 deployments do a much better job than the more mature ones. But this one is the one that's kind of got me scratching my head, and I'm not just looking for spare hair. I haven't got any to spare, but why? Oh, why? At just around 1360 octets, does the drop rate, which was around 9 to 10%, suddenly become 16%? Wow. Unusual, not expected. We actually look at the regions and we find Europe has the most pronounced, Asia does it to some extent, and in the Americas, it's not so pronounced. But, you know, the larger fragments actually have a higher average drop rate. Interesting. I can look at various providers like TELUS in Canada, 95% drop rate. It's all horrible. But Bharti in India, a relatively recent deployment, the drop rate's around 4%. It's brilliant. And so service providers and their equipment and configs seem to have a lot to do with this. Local security policies, because some people don't like fragments. I don't think TELUS likes fragments. It's just, you're fragmenting, I'm going to drop you. On behalf of my users, go away. Interesting. Extension headers, we're just not sure, but maybe that's a problem. Path empty UOs. And there's a more complicated area that I haven't got time to go into here, but I think there's some interaction with the TCP MSS settings that bias things for bigger packets. Is this fragments are bad, or is this extension headers are bad? Good question. Why don't we try an atomic fragment? Now, an atomic fragment is a v6 packet with a fragmentation header, but the offset is 0 and the more bit's 0. So in other words, it's just a filler. The entire packet is there. It's just got a null fragmentation header. How does that go? Well, I'll go back to that original picture I had and now point you at the red line. When we do an atomic fragment, the drop rate is now around 6%. That's a drop rate about extension headers and maybe a relatively stupid form of fragment filtering that doesn't actually check to see if there's a fragment, but it may have something to do with extension headers. Interesting. I compare a number of providers. Most of the time, the atomic frag drop rate is around a third of the normal drop rate, except when it's not. In Germany, for example, it's all the same. It's around 17%. Doesn't matter if it's atomic or a real frag. Probably a problem with extension headers. Italy, extension headers are fine. Fragments, 25% drop rate. Oops. Australia, the atomic frag drop rate's higher than the normal frag drop rate. Telstra, what gives? I have no idea. I really don't. And no one's ever answered. Maybe I've never asked the V6 folk in Telstra because they're the major V6 provider in this country. So it's interesting. There are different behaviors. And so the atomic frag wasn't really as informative as I would have liked. I would have thought this would have been more clear. So let's look a bit wider. Let's see if it's a destination option. So we're using PAD-N. This is the destination option you have when you don't really have a destination option. So it's kind of, I'm just going to put some padding characters in. It doesn't mean anything. And if you get it, it shouldn't change your behavior. So let's use it because hopefully we can now see what's the drop rate when we just send packets through that are normal packets. I'm not fragmenting. I'm just putting an extension header with a padding destination option. Now, whoa. Let's go back a second. Let's go all the way back here. We're back through the time machine. Destination option, drop rate, 10, 11, 21%. Last week, whoa, 94.5% drop rate. Whatever you're doing or whatever hosts are doing, or somebody, it's either network or host, you don't like destination option extension headers at all. They're just dropping it. 94.5% is really awesomely bad. Now, it's so high that I'm kind of wondering if my experiment isn't working right. But maybe it's a destination option. Maybe platforms like Linux and Android and iOS simply go, look, it's a destination option. Go away, drop. let's try a hop-by-hop extension header, one that travels through the network and has absolutely no meaning to the destination. So the destination, if it receives a packet with a hop-by-hop extension header, should go, nothing to see here, strip it out, continue processing, we're cool. So this should give us some idea of the network treatment of extension headers. Yes, it's padding, so there's no special semantics. So the network should accept it. Yes. Wow. It's not just bad, it's badder. That's awesomely badder. That's even badder than the last one. If you put in a hop-by-hop extension header, you can guarantee the packet won't make it. That's when you get numbers like that in an experiment, your immediate reaction is, I've got something wrong. I've got something wrong. I'm like, the original thing back there, remember 2014? 20, 30, 40%, not 99.5%, 99.5. And so all of these drafts that are coming out in the IETF, let's use extension headers to do mumbledy, 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 to do some kind of signaling, mumbledy, mumbledy, mumbledy. Let's put it over the internet and watch it sink like a stone. Because that's just, let's give up. This is horrible. So where are we? Because, you know, I've almost used up my time. For fragmentation, we're getting better. We've gone from that's unusably awful, don't fragment, it doesn't work, to a point where it's kind of, well, for 5% of the folk, it doesn't work. For 95%, it's okay. So it's kind of, yeah, it's not very good, but it's tolerable, I guess. Don't fragment, but, you know. And recent deployments are better than earlier deployments. The equipment is getting better for fragmentation. But destination and hop-by-hop, whoa, dead. Just not supported on the public internet. Sure, you can roll your own and do whatever you want, but out there in everyone else's networks, it just doesn't work. So what lessons? If you're in V6, don't fragment. Whether it's DNS or anything else, don't fragment. And don't rely on path MTU discovery because it doesn't work. And don't rely on extension headers because they don't work. And don't rely on ICMP6 because that doesn't work either. There's a lot of icebergs out there in V6 land, and steer your craft through those icebergs very carefully. If you pick 1280, you're below most of the noted problems. You will steer through this and not really encounter any more than the normal V6 stuff. It's okay. You can raise it as high as 1350, and it's kind of a bit more efficient. You're packing in more data against the header. So it's kind of Goldilocks choice. It's kind of a little bit better than tiny and still survivable. 1400 octets, 15, for some reason, and we're not quite sure exactly why, the failure rate rises a fair deal. So bad choice. And what about hop-by-hop and destination headers? Well, the answer is simple. They don't work. You can see all this and more on a day-by-day basis, country maps and tables per country, tables for your favorite provider, tables for you if you're an operator that measure the performance of fragmentation for your customers every day since, early 2021, I guess. So there's some time for questions. If there are any, I will hand it back to you, Kenny, and see if anyone's got questions. Thank you.
Right, thank you, Jeff. Basically, we moved Q&A to the final section, and thank you, Jeff Hewson, for providing a very unique view on IPv6 fragmentation. And most of you probably are operators, so just try to familiar with that kind of issue and try to avoid the fragmentation as much as possible. Thank you, Jeff. So right now I move to the next speaker, John Alexander. He's going to introduce OZ Broadband IPv6 deployment journey. I pass to John. Thank you.
Thank you. I'll just share this. Okay, hopefully everybody can see this. I can't see that. I can see that you're seeing this.
You're
yes, good. Okay. Yes, so our journey started way back in 2009 when I joined Aussie Broadband. I really wanted IPv6 out then and there, but we had all kinds of issues and things. So the simplest thing that we did right at the start was put our servers on. It just worked. They were mainly FreeBSD. We had no issues and it worked, but we didn't have our end users on there. And so it took us until about another 9 years before we decided to actually get it working properly. So our pre-alpha stage, we did a thing similar to what HE does with their tunneling. We did a IPv6 over IPv4 and gave a customer a /64 address so that they can start playing with their internet. And this worked well, except only if you're in Victoria. For those that know Australia, that's where our tunnel endpoint was. For anybody else, if they were in Darwin or in WA, they had to travel across to Victoria before they'd get an IP. So it worked, but it wasn't ideal. We wanted to hand them a proper IPv6 address via DHCP through our national broadband network, for those that are aware of what that is. But we ran into a problem. The router vendor that we had, I'm not naming any names, but I think it was public ages ago, had an issue where the DHCP packets that were sent to the end users for V6 had a DHCP marking set on them, and we couldn't change it. In NBN land, they dropped those packets, so they were unable to get the V6 address that we were sending them. It just didn't work. So we couldn't do it properly until our router vendor was able to fix the DHCP DSCP issue. You can see Phil, which is our CEO, he did a talk on that at OSNOG in 2018. We raised the bug and it did get fixed about a year later. So that it did allow us to start doing DHCP for customers. So on the 20th of November 2018, we released our beta program, and everybody was able to get a 128 WAN IP for their router, and then they got a /56, which we allocated them out of a pool of a /40 for each BNG that they are connected to. So we had a /32 from APNIC, and we allocated /36s. So we divided the our pool into various smaller sizes to be able to allocate them out. So as you can see there, we had the first part was for our network and servers and so on, and then we divided the rest of our /32 into 36 ranges so that we could handle it more easily within our network. You can see the VPN tunnels. What we had originally was the A000 network. All the other states then had the 36s. This is an example of what it would look like. You get and IPs have been changed to protect the innocent. You can see the IP address, the V4, you get a normal V4, and you get a /128, which is the one ending in E62E. And within that would be routing a /56 address to that 128 address, so that then on your home router or business router or whatever, you could then subdivide that /56 to your heart's content. That's entirely up to you. And that was working really well. This allowed us to handle about 64,000 customers, or 64,000 /56s per BNG, but our BNGs could only handle 32,000 customers, so we had no issue. We also had 15 /40s, which is where we made the 36 come out of. Oh, sorry, where the BNGs got their 56s out of. There's too many prefixes here. With the discussion, we were getting some customers that wanting /48, say, for whatever reason, they wanted 48s instead of 56s. So we're discussing how are we going to do this. So we decided we'd try and standardize on a /48 for everybody, whether it was a business, a corporate, or a residential user. Just keep it all the same, makes it much simpler for our for our network, our customer management system, to be able to handle it. So we then decided, well, how many IPs do we need? We need quite a few for the numbers, and I've got my slides out of the wrong order, but we were advertising the 36s. For the 48s, we could handle about, as I scroll through this one, for our 48s, we had a /32, so we could only handle 64,000 customers. That's no good for us. We had about close to 500,000 customers, so that's not going to work at all. So we decided we needed to get more IP space. So we applied to APNIC for a /28, and we managed to get it. And you can see here we decided I was advertising the /28 through HE, but you could also see the /36s. So much to Jeff's chagrin, yes, we were dividing up our network into smaller ranges, but we got rid of them. This was how we did our advertising, as you'd say, on our BNGs. We did a static route for a /36, and we advertised it out into our internal network. So the rest of the world didn't see it. Why did it take so long? Rome wasn't built in a day. IPv6 has been around for so long, but the initial problem was the BNG software. That took until 2019 to be fully fixed. That then allowed us to do DHCP properly, but we still had another problem, the CPEs. So some of you may know Mark Smith. He was doing work on CPEs at his previous job. He now works at Aussie Broadband. So he was doing more work with our router vendors at Aussie. And the main thing that we had was the routers didn't enable V6 by default. That's just, well, it's a big issue. If you don't have V6 by itself, an end user is not going to know how to do that. They're going to have to call up, or we've got to call them to be able to enable it, which is a big problem. So the first one was to get the router vendors to actually enable IPv6 by default. That's been done. We also had DHCP or V6 on the WAN interface stopping after a few days. It just decided to stop. The only way to stop it or fix it was to either stop and restart the DHCP service on the router or reboot the router, and that's not feasible either. There were other protocol parameters such as DHCP timings and things that were set incorrectly according to what RFC defaults were set as. Mark was able to get those changed so that they're now correct. And we also had some working where you may have a VDSL connection and it would work on that, but it wouldn't work on the Ethernet connection. So if you had fiber to the home, IPv6 wouldn't work on the Ethernet connection, but if you had fiber to the node, it would, because it would be going over the VDSL connection. So again, that had to be fixed. Mark's observations to us were the CPEs actually were worse now than what they were when he was looking at them in 2011. So he was looking at that in 2021. So 10 years later, it's actually got worse, but he's managed to get our two main suppliers working again, and IPv6 now works out of the box, which is a good thing. However, there's lots of bring your own devices that do not, and so it's still an issue with end users being able to just turn their modem on and hope that IPv6 works. But we're getting there. So as we were going along, we had the option I discussed earlier of keeping the 56s, which would have fitted in all of our customers, or change it to /48s. So we did change it to 48s because the cost of us doing it, which is good, with APNIC, they charge the higher of the two things. So in our case, our IPv4 range was costing far more than the V6. So we looked at upgrading it to a /28, and we did that so that we could then handle enough BNGs that we had, which we could handle 30 BNGs. The issue we had now is we're putting in more BNGs than 30, so we needed to increase our range from a /28. So I applied earlier this year for a /27, and that would give us the capability of having 2 million /48s. At the moment, we've got at the moment with a /28, you could have a million /48, so a million end users. We're going for 2 million, so we really shouldn't run out anymore. So I applied for that. Our BNG support had a /33 assigned to them, which would give them 32,000 customers, 32,000 IPv6 addresses, so it worked fine. The /27 gave us much more breathing room, and we now have that. And much to, which will make Jeff happy, we are now only advertising the /27. I am still advertising at /32, which was our original /32. The issue I've come up with that is if I drop it, there are some networks in the world, not us and not our upstream providers, but further afield, they decide to have or not drop those routes, so that they'll keep advertising the /32 for whatever reason. So they'll become the preferred route instead of our 27 and basically black hole us. So we've got some issues with our upstream providers having some issues there. So that's why I've still got the /32. I do have a couple of /48s there for server things as well. The issue that we've got, and I saw a question just pop up, why have we got, I'll just find that, why have we got, would need more than a /56? Well, some businesses want a /48, so we decided to do a /48 to make it simpler, and there's plenty of it available, as somebody else there just said. What we've got though is, at the moment, each BNG has a the /33 assigned to them. So if a customer lands on that BNG, they'll get their IP. But if for some reason they shift house or we do some network changes and they land on a different BNG, they will get a different IP address. So we haven't got a proper fix for that yet. We are looking at just doing a within a state IPv6 BGP advertisement, so that all of the BNGs within a state will share the /48, so that if you do change a BNG, then you'll be able to keep your V6 address. But at the moment, it stays within that one BNG. We'd end up with 288,000 odd routes in Victoria, but that should be okay as long as our routers are supporting it. But 48 works. We now have a /27, so I don't think I'll be ordering any more IPs from APNIC anytime soon. So what do we see in our network now? All of our customers are getting V6 addresses when they sign up. So all new connections now get their routed /48 to them, and they also get the /128 address for their WAN address. We've retroactively applied it to about 60,000 customers that we were seeing V6 addresses. They were trying to get V6, but we weren't handing it to them. So we've now given it to them. So they're now working with V6. And we've also, in the process of some of our routers, we're able to remote manage and turn on V6 as well. So we're doing that as well. The next step is to basically turn it on for the rest of our customers and try and get everybody to start using it. We have some monitoring for the actual V6 use, but it is disappointing on a desktop. If you have V6 and you stream Netflix, they'll come over V6, or you watch YouTube or watch anything like that, it's okay. But the TVs don't have V6. So if you're watching Netflix on a TV, it will still revert back to a V4 address. If you're running, or if you're wanting to watch YouTube on a TV, again, V4 only. So it's an issue. We still need the Internet of Things, i.e. TVs and any other devices, to be able to support IPv6. Otherwise, we're still stuck back in IPv4 land. IPv4 is running out. It has run out. It is getting very expensive to get more. We need everybody to go to V6. The problem is not everybody is yet, and we're trying. We need the router vendors to do it, and we need the Internet of Things devices, i.e. TVs, set-top boxes, etc., to do V6. But if you have it, it works really well. And Tashi is just saying, yeah, nibble bytes /48s are really easy to look at as well. Instead of playing with 56s or 60s, it makes it harder to work out what your range really is. 48 is really easy. That is our journey. We're getting there.
Okay, thank you, John. You finished?
Thank you.
Okay, right. Thank you for sharing your IPv6 deployment experience. And I found there are some discussion in the chat room. Probably we can move back to join the discussion during the Q&A section. So right now, I'd like to move to the last speaker, Charles Liang from Taiwan Mobile. He is going to introduce Taiwan Mobile IPv6 deployment experience. And let's pass to Charles.
Okay. Good morning, good afternoon, and good evening, ladies and gentlemen. I'm Charles Liang from Taiwan Mobile. It's an honor to receive APEX and TW's invite, and I'm here to present the current deployment of Taiwan Mobile's IPv6. Next page, please.
Sorry, Charles, to interrupt. There's some issue with the voice. Can you please turn off your audio or speaker if you're using a speaker? Because it's echoing at the moment.
Yep.
Can you please try to turn off your speaker?
Is it okay now?
No, it's still echoing. Can we test again, please? Can someone unmute him?
So is it okay now? Still?
I think, please go ahead, Charles. Thank you.
Okay, I'll go ahead. I'm fully agenda for my presentation. First is the company profile of Taiwan Mobile. Next page, please. Taiwan Mobile was founded in February year 1997. In January year 1998, a 2G mobile network started operating with a 0935 mobile number. In May year 2000, Taiwan fixed network was established and got the fixed network service license in year 2001. In July year 2001, Taiwan Mobile merged Chensesa Telecom, a mobile operator of southern Taiwan. In August year 2004, Taiwan Mobile merged Mobile Communication, a mobile operator of central Taiwan. And in May year 2005, Taiwan Mobile introduced the leading 3G service of Wi-Fi CDMA system. It's the start of the 3G VO era. In April year 2007, Taiwan Mobile merged Taiwan Fixed Network, a cable company Taiwan Fixed Media, and Taiwan Telecommunication Network, and got the management right of these three companies. In June 2014, Taiwan Mobile introduced 4G and started providing 4G service. In July 2020, Taiwan Mobile launched 5G service for the open passport. In December 2021, Taiwan Mobile merged Taiwan Star Telecom (T-Star). After that, the total number of subscribers is about 9.8 million. In February 2022, Taiwan Mobile earned over 1.1 5G subscribers. Next page, please. The corporate business service that Taiwan Mobile mainly offers are in the following three categories. The first one is mobile network service, mobile broadband internet, cloud game. Taiwan Mobile could work with NVIDIA to provide the geopositional games, and could work with Royal Games to provide the needs of Beijing serious games. Momo e-commerce. Momo is a company that is 100% owned by Taiwan Mobile.
Sorry, Charles.
Yeah.
Can you also check your speaker? Probably you need to turn off your speaker, but because we still have a quite serious echo in the room. So can you check your microphone and speaker? Make sure and speaker. 你的喇叭要不要关掉？ Can you try again?
Is it okay now?
No, Charles, can you try to remove your headphone and just speak directly to the speaker of the laptop?
Or
The laptop.
You turn off your speaker at your laptop. Just using the mic.
Okay. So is it okay now? I just use the laptop. Is it okay now?
Using laptop, and do you turn off the speaker in the laptop?
I just kill the volume.
Can you test again? Hello? Hello, can you test again? We couldn't hear you.
Is it okay now?
Yeah, it's good. Okay, keep going.
Okay, I just take up my head ear. So I continue to my presentation. Cloud game, Taiwan Mobile co-works with NVIDIA to provide the geopositional games, and co-works with the Royal Games to provide the needs of Legion serious games. And Momo e-commerce. Momo is a company that 100% owned by Taiwan Mobile. Taiwan Mobile provided Momo the speed pass B2B to C service when 5G service launched in year 2020. My series and Disney Plus services, my video, my music, and my book and Disney Plus services. Smart Schedule. The mother company of Taiwan Mobile is Fubang Group. Fubang owns two professional teams. One is Fubang Guardian baseball team, and its hometown is in New Taipei, Heping, Xinzhuang Baseball Stadium. The other one is Taipei Fubang Braves basketball teams, and its home game is in Taipei, Heping, basketball stadium. These two smart stadiums use the services of immersive virtual reality 360-degree live video broadcast, multi-view video streaming, 4K ultra high definition video, 3D real-time replay, and the coming AR, MR, VR, multiple access, edge computing technology, and so on. The second one, Pwm Broadband, is the brand name of cable network services, cable broadband internet, cable and digital TV, pay TV. Since the customer don't want to pay the whole cable monthly fee because they don't watch all of the channels, customer can choose this pay-as-you-go service to select the specific channels they want. 5G plus Wi-Fi 6 bundle service is so-called 好事成双. It's a service that customers use 5G network service outdoor and Wi-Fi 6 with fiber service at home. Customer only need to pay a mobile monthly fee. The cable broadband internet with Wi-Fi 6 is for free, home security, and so on. The third one, TWM solution, is the brand name of the fixed enterprise services, fixed broadband internet, mobile office, cloud PBX. Customer smartphone can be as the extended number of the office PSTN lines, data center, cloud service, cybersecurity, 5G enterprise, private network, and so on. Next page, please. The usage rate of IPv6 as of February year 2022, Taiwan had a ranked number 15 in world ranking with a usage rate of 43.7%. Taiwan Mobile's IPv6 usage rate had reached 79%. For your reference, the picture on the right is the growth chart of Taiwan Mobile's IPv6 usage rate. Next page, please. This is the Taiwan Mobile's current situation on IPv6 connection section and traffic throughput as of February year 2022. IPv6 connection section had reached 4.5 million. IPv6 traffic throughput had reached 532 gigabits per second. Next page, please. Taiwan Mobile has cooperated with many global content delivery network companies. Take Facebook as an example. As of February year 2022, the statistics showed that in year 2019, the usage rate of IPv6 was 66%. In February year 2022, the utilization rate of IPv6 has come to 91%. Next page, please. This is my final slide today about the current challenge and future prospects. We came up with 3 conclusions. The first one is the upgrade from 4G to 5G. Because of the intense competition among the 5 telecom operators in Taiwan and the influence of the all-you-can-eat rate plan, the users of 4G have gradually saturated. Besides, the median and lower-end 4G smartphone don't support IPv6. Only 5G smartphone support IPv6 and V4V6 dual stack. So it's a critical issue for every telecom operator to figure out how to upgrade their 4G user to 5G immediately. If this upgrade succeeds, we will be able to increase the usage rate of IPv6. These are 2 phases of strategy that Taiwan Mobile will conduct. Phase 1, we will encourage 4G medium and low-end smartphone users to upgrade to 5G when their contract expires. However, if the user rejects the upgrade because of the price of 5G smartphone. We will advise the user to try a 4G high-end smartphone in a cheaper, discounted price. In this way, we can not only help some users upgrade to 5G, but also increase the usage rate of IPv6 from the support of IPv6 and V4v6 dual stack of 4G high-end smartphone. Phase 2, when the price of 5G smartphone becomes more acceptable and affordable, we can encourage the user to upgrade. At that time, not only the user can enjoy some higher speed and low latency internet service, the usage rate of IPv6 will increase as well. The second one is IoT device increase the usage rate of IPv6. Although there is already device for 4G, it faces two problems. The first one is because the design of IoT software did not consider the interworking with the network side. It occasionally faces some overloading problems of massive signal registration after a software update. The second problem is because the cost of IoT device is cheap. When it leaves the factory, only electrical character tests are considered. Therefore, without a complete wireless radio signaling strength, quality, and a narrow access test of protocol signaling, it can trouble the telecom operators. Most of the 4G IoT devices don't support IPv6 because of low cost issue. The usage rate of IPv6 will increase significantly if 5G IoT devices support IPv6 and V4v6 dual stack in the future. As for the future prospect of these two problems, there are three scenarios of 5G defined: enhanced mobile broadband, ultra reliable low latency communication, and massive machine type communication. Among them, massive machine type communication is one of the scenarios that is designed for IoT device. After the technique of 5G massive machine type communication, going with the narrow slicing become more mature, the problem of massive signaling registration after software update can be solved. About the second problem, in the future, 5G IoT will have the past experience of 4G, so we hope to strike a balance between cost and quality. Besides the electrical character test, we will also pay attention to the better design of signaling strength, quality, and protocol signaling for wireless radio. Also, with a strict narrow access test from the telecom operator, the second problem can be solved. The third one is B2B and B2B2C business. Enhanced mobile broadband. One of the service scenarios of 5G is the extension of 4G. The new ultra reliable low latency communication and massive machine type of communication belongs to the business of B2B and B2B2C. In order to let 5G improve substantially, how mobile will work its magic in mobile service to combine Momo's merit in e-commerce and integrate the resources of the company. At the same time, we will upgrade users' experience to boost improvement in the usage rate of IPv6. This is my presentation for today. Thank you for your time. Thank you.
Thank you, Charles. Thank you for your experience sharing on Taiwan mobile IPv6 deployment. And so we have all speakers finished their presentation. I'd like to move back to our MC, Anna, and she will help to handle the rest of Q&A section. Anna, the floor is yours.
Thank you so much, Kenny. I can see that there's already a lot of discussions happening on chat. One of the things that's being discussed is about the size of prefix that is assigned to end users, especially for residential customers. And one of the comments here says, is /48 or 56 good or bad? Are there any comments from our speakers about that question? or comment?
Well, that was my comment. I'll say why we actually put it in. Just the way our management system and so on worked, it was easier to have a single range for everything than having a /56 and a 48. It just didn't work as well for us. So we just decided to keep it as a /48 and just do it like that. And I can see Jeff doing all kinds of
John, you
things.
weren't alive in 1988, were you? Because folk were telling us the same thing about Class Bs and Cs. It was just easier to give out a /16 and a / and when we ran into the problem that we needed to make this last longer than next year, we had to go back and build back in CIDR. The question to you is really, how long do you want this generation of technology to last? Knowing that after 10 years, in fact, 20 years of transition, we're still trying to get through the last one. And so this idea that V6 has to last for 10 years, we don't think that anymore. I think all of us would actually say we need this V6 address plan to last for, 100. Because changing that underlying platform in a dense Internet of Things is almost unthinkably difficult. And so if we want to make the address space last longer, we've either got to contemplate NATs in V6, which I know I've just sworn at people because no one likes NATs in V6, or you have to exercise some restraint early on. Now, I know it's more work, but even if you said a 56 unless you pay me more money, you're an enterprise customer, even $10 a month, to naturally sift out big versus bigger. Because most residents, a /56 is wow, The early days of Internode, they were giving everyone a /60. That's what I got from them. And I actually didn't notice a problem. 4 subnets was actually 2 more than I needed. A /56, play space. A /48, a waste of everyone's time, including mine. Now, if you want V6 to last for 20 years, do what you're doing. Because I can guarantee in 20 years' time in the silicon dense world, we'll be sitting there going, wow, where did all the addresses go? And so it's about making your life easy today, absolutely, but thinking about your poor children who have to inherit the mess you're going to create in 20 years' time. We have to fix it all up again. And, and that's the balancing act in address plans.
Is that in relation to advertising the 56s and 48s within the network, or because obviously we don't advertise 56s out to the rest of the world? So
it's not about the routing table. It's just about how quickly we get through addresses. If you think about it, it's not 128 bits long. It's only 64 bits, but you're allocating /48s as if they were 24s in V4. And so the consumption rate is actually quite high. And you go, well, yeah, it'll last a couple of years. Absolutely. But when we talk about 20 or 30 years, it's not so confident to say no problem. And that's the tension about, do we take the pain now based on what we learned in V4, or do we just repeat those mistakes? Because, it's easier to repeat the mistakes because it is. That was the issue. But, my view, if I was doing this and I was in your seat, I would seriously think of a /56 for free, part of the base service. And if you want to be enterprise, I'll give you a permanently assigned, so it's static, /48 mapped in with DHCP. So you can run services, you can actually be what you want to be, but it's going to cost us all because I'm going to nail that address down, give you the larger prefix, we're all happy. But I'm not running a business, it's you. So, take this advice for what it's worth, nothing.
Thank you, Alex and Jeff. I think there are a few more comments, but we ran out of time. So we can take our discussion maybe in the conference chat. There's a technical group chat there that we can continue the discussion. So once again, I'd like to thank Kenny for moderating the session, and also to our speakers, Jeff, Alex, and Charles. I am now closing the session. So if you can please complete the poll survey. It should be popping on your screens right now. And please join us at the daily quiz, which will be happening after this session, and then the peering socials after that. Thank you so much for joining us tonight, guys, and we'll see you tomorrow. Bye.
Bye-bye. Thank you.
Thanks.